Welcome to my explainer video on temperature logger sampling rates. This video is intended to explain what the sampling rate is and how to have it as slow as possible without losing critical information. This idea applies to every brand of temperature logger or data logger. Let's assume we are monitoring the temperature of a regular event which looks like this. This could be the temperature of a fridge and the cycle could be a couple of hours long, or it could be the temperature outside, in which case the cycle length would be 1 day. Either way, the results are reasonably constant. So let's introduce a spike in the temperature. A temperature logger doesn't record every instant of time. Instead, it will record the temperature at a given frequency called the sample rate. These lines represent the moments in time when it will record the temperature. And those dots represent the time and temperature reading that were made at these times. If we hide the original temperature, you see that we have a series of readings, and this is what is stored in the temperature logger and downloaded to the computer. We then join these dots up to make a continual graph again, and this is what you see on the screen. If we now compare this with the original temperatures, we find that it is a fairly good approximation. We missed a bit from the top of the spike, and the graph looks smoother than the actual temperature, but this is a good approximation. The other thing to note is that we were able to get a good estimate of the 5 cycles using about 30 readings. We weren't swamped by too many readings, and the memory in our temperature logger will last for hundreds or thousands of cycles. If we were to sample more often, we would be swamped with too much data for no real benefit. Now let's do the entire exercise again, but this time we are going to slow down the sampling of the temperature. So it is the same temperature, but now the readings are further apart. And we have half the number of readings. Now when we look at what is downloaded to the computer, we see that there is only half the number of readings, but we still have a reasonable approximation of the original. For most applications, this is still sufficient information, but only just. So a simple rule is to try and have at least 5 points during a cycle, but we will cover the most important rule next. This time we will do the exercise again, but slow the sample rate again by halving the number of samples. Now we see two very interesting things happen. Now we think that there was only 2 cycles instead of 5, which normally isn't too important, but when we compare it to the original, we see the real problem. We totally missed the spike. By having a sample rate that is too slow, you are likely to miss a critical event. So here are some simple rules you should consider when setting the sample rate. 1. Work out how long an event needs to be before you want to know about it. You then want at least 3 samples in that time. So if you want to pick up a problem that lasts for 30 minutes, then you need to sample at least every 10 minutes. And 2, since the exact time can be out by that time, do you want to have a better idea as to when it started and stopped? In most cases you don't. Practically, most customers are monitoring fridges. The reality is that a short surge in temperature won't change the temperature of the contents. And so a change that lasts over 30 minutes is what you need to know about. So a sample rate of 10 minutes is a good starting point. If, however, you want to know the moment something was taken out of the fridge, changing the sample rate to 1 minute will give you a much better idea. For most people, however, a fast sample rate has the problems of filling up memory too quickly, needing to download more often, and drowning in excess data. This video is intended to show how to reduce the sample rate without losing critical information. Thank you.